today on behalf of the PO East Toronto chapter, the host of today's seminar, and the climate change group. I would like to welcome you all and thank you all for joining us. Before we start, I would like to remind you all to keep yourself or your mic on mute. And I would like to remind you also that today's seminar will be recorded. In today's agenda, we will start with the land acknowledgement and the introduction with the presenter. Follow that. A few questions will be shared with you to vote on in a poll session. After that, our guest speaker, Mike Prsa, will give his presentation. Please feel free to put all your questions in the chat box or scan the barcode appear on the screen to put down your question throughout the presentation and the seminar session. I would like also to express my appreciation for all the co-sponsors working hard together to make this event happen. Without the support and the collaboration, we cannot go so far. Now, please welcome our co-sponsor representative and members from the PO East Toronto chapter, the lead chapter, PO Ottawa chapter, PO York chapter, PO London chapter, PO West Toronto chapter, PO Peterborough chapter, PO Toronto Humber chapter, and the Toastmaster Speaker Club of Ryerson Engineering with the Toastmaster Engineering of Club of Speakers with the organization of IEEE Peterborough section, with the Society of Women Engineering Ottawa, and lastly with the Society of Women Engineers Toronto. I hope you all enjoy the seminar, and with that, I will pass it over to Christy. Thank you.
Hello, everyone. Good evening. I'm Christy Gore from Ottawa, the seminar chair of the Ad Hoc Climate Change Group. I'm so excited to have you here tonight to learn, share, and discuss our climate challenges, potential solutions, and climate change adaptation and mitigation. I would like to start my introduction for the seminar by acknowledging that we are meeting on Aboriginal land that has been inhabited by Indigenous people from the beginning. I want to show my respect for their contributions and recognize the role of treating, making what is now Ontario. Hundreds of years after first the treaties were signed, they are still relevant today. We are grateful for the opportunity to meet here, and we thank all the generations of people who have taken care of this land for thousands of years. Climate change is becoming a significant topic, and we cannot avoid and should take care of this planet as soon as possible. This seminar is organized under a group of people at the PEO who care about climate change and really want to make a difference based on our multidisciplinary background. Our mission is to help engineers, practitioners, academics, decision makers, and the regulatory committee members to set a vision and work on action plans and strategies for climate change adaptation and mitigation in Ontario. Now, I will pass my torch to Sadiq to introduce our guest speaker, Mike Prsa.
All right. Hello, everyone. My name is Sadiq. I am a member of the SCORE Toastmasters Club, and now I will introduce our guest speaker, Mike Prsa. So Mike is a make it happen hands-on leader on several key fronts at Mulvey and Banani, filtering out real substance from a crowded marketplace of ideas and possibilities. Mike is a multifaceted engineer working effortlessly across electrical, ICT, security, and building and intelligence engineering. Mike directs the firm thought leadership for building intelligence and PropTech and the role it plays in overall building sustainability, decarbonization, and user experience. Actively engaged in the industry, Mike currently sits on the CSA Group Building Intelligence Standard Executive Community, as well as the CSA Group ICT Code Technical Subcommittees. With a forward-thinking mindset, identifying emerging industry trends, and selecting opportunities for the firm keeps Mike motivated and passionate about his work. With Mulvey and Banani since 2007, featured projects in Mike's portfolio include the Kempegowda International Airport Terminal 2 in Bangalore, India, as well as many building intelligence projects, including Place, Phase 1 and Phase 2, which won the 2019 Hoop Leap Award for Innovation, as well as the Bay Adelaide Center North, Portland Commons, Sick Kids Patient Support Center, in countless digital transformations and standards for all client types, including municipalities, developers, and end users. So I will pass over the torch to Andreas, who is our poll questions moderator.
Great, thank you very much, Sadiq. So what we're going to be doing now is just to run a poll, just to see what everybody's thoughts and perceptions are about building intelligence prior to Mike's presentation. So I'm sharing my screen here. Get this up. Oops. And if you want to participate in the poll, you can do one of two things. You can either click on the link that's in the chat box, or we have a QR code showing up here on the screen. If you want to just access that from your smartphone, you just basically start your camera app, aim it at the smart code. You should see a link come up at the top of your screen. Click on that, and it'll open up the poll in your phone itself. So I'll start with the first question, and just give everybody a little bit of time here to either get to the link on your computer or scan the QR code and access it on your phone. The first question is, what is the most important outcome of building intelligence? So in your opinion, do you think it's more about OpEx savings, like operational cost? Is it about sustainability and decarbonization? Is it mostly about user experience? Or do you think the biggest bang for the buck here is about user wellness? So give it a little bit of time here. We've got 16 people already voted here. That's great. Good stuff. So we've got 27 people that voted already. We give a little bit more time for a few more to get to the link. And then as you're listening to Mike's presentation, you can think about some of these questions and see if your thoughts or your perceptions have changed by the end of the presentation. Good stuff. So we got about 30 people that have voted so far. It looks like it's slowing down. So I think most people have voted that are going to. So we'll skip to the next question. What I'll do is at the end of the there's only 3 questions. At the end of it, I'll show the results for them. So question number 2 is, what is it that makes a building smart? Is it more about converged building network? Is it about Internet of Things sensors or IoT sensors? Is it about data extrapolation? Or is it has it to do more with the analytics and machine learning? So again, in your opinion, what do you think is the biggest component that makes a building smart? Good stuff. Got about 27 so far. It's awesome. All right, we're up to 30 again. So I think that's, there's 31. So a little bit more than the last one. All right, we'll go now to question number 3. How can building intelligence help combat climate change? Is it about reducing energy use? Is it to reduce operational inefficiencies? Is it through increasing equipment lifespan and uptime? Is it through increasing awareness, or do you think all of the above would apply? And again, give everybody a minute or so to cast their vote, and then we'll go back and show the results. Great, we're up to 29. Let's see if we can hit 31 there. All right, looks like that's about it. So what I'll do now is I'll go just back to the first question and we'll take a look at the results here. So, you know, what is the most important outcome of building intelligence? Most people think that it has to do more with sustainability and decarbonization at 50%, 20% said OpEx savings, 20% said user experience, and lowest one was user wellness. Question number 2, what makes a building smart? Majority of people thought it was more about analytics and machine learning. Some thought it was converged building networks. 16% said it was about Internet of Things, and 6% said it was about data extrapolation. And question number 3. How can building intelligence help combat climate change? Everybody said all of the above, which I figured is probably the right answer as well. We'll find out when we listen to Mike's speech. So without further ado, I will stop sharing my screen and we will pass it over to Mike to start his presentation. Please welcome Mike Prsa. And there we go.
Beautiful. Can everyone hear me?
Yep.
Thank you today for a topic that I'm personally very passionate about, and all the benefits that come from building intelligence. And we touched on some of those a little bit in the
Mike, I think you are.
We lost Mike, I think.
He's here, but we cannot hear him.
Hi, can you hear me? Sorry about that. I'm not sure what happened. And we're back on. Everyone can see my screen?
Yes, perfect.
Perfect. Okay, let's try that again. Thanks again. Good evening, everyone. Thanks for joining. I'm definitely going to jump right into sort of building intelligence, and most importantly, what building intelligence is, what makes a building smart or intelligent, and then moreover, how that lends to decarbonization and overall, effect on climate change. The agenda for today will be basically what is building intelligence, and then we're going to look a little bit about the evolution of systems and technology in the built environment and how that progressed over time to where we are today, and a little bit on where we're going to go in the future. We're going to talk about market trends and business drivers. So, anything that's built, is built for a reason typically. So there has to be some things that are driving some outcomes, whether it's KPIs or ROIs, why people are doing this and the benefits coming from it. We're going to look a little bit about the enabling foundation. There's some building blocks that you absolutely need in order to deploy smart strategy in a building, which are, founded on ICT. So that's information, communication, and technology. We're going to talk a little bit about building intelligence pillars. So, as the industry continues to move forward, there are some core pillars on, sort of the definition of building intelligence and the different levels that you can take it to. Then I want to just jump into some sample use cases, which, in the industry or the actual end functionality, just to give the group an example of, real world examples of what we've been doing in buildings and where we're going with it. We're going to move into building intelligence architecture, which may be getting a little bit technical, but after we talk about some of these principles for 30 minutes or so to actually from an engineering standpoint show the architecture, how pieces are connected and how that all gets pulled together in a built environment. And then we, of course, want to wrap it up at the end with, what are some of the KPIs and the ROIs, so the key performing indexes or the return on investments, which are driving people to do some of these above and beyond all the great things such as, decarbonization and various different levels of efficiencies. So without further ado, the magic question typically is, what is building intelligence? And that definition has, changed over time. And realistically, there's a difference between smart and intelligent. Smart is, knowing facts and being able to, regurgitate those facts in order to make a point. And intelligence is is really being able to ingest new ideas and new data and then come out with your own outcome. So, that's how we at Mulvey, Banani, and myself see the difference between smart and intelligent. And we're going to touch on that last piece on the intelligence a lot throughout this sort of seminar here. But right here, what do we see as, creating intelligence in a building? And of course, fiscally and environmentally responsible assets. So, while we are aiming for sustainability and decarbonization and user experience, we also do need to mirror that with business outcomes and business goals as well to come up with a happy medium. We're looking at asset performance, whether that's operationally, optimizing your OpEx costs, your energy usage, your uptime, your equipment lifespan. So increasing all of the operational benefits of the building. Future enablement is huge as well. As a minimum, we see most, buildings preparing for a smart strategy as a very minimum. And, the way we're designing buildings these days is, doing a lot of upfront design, a lot of upfront coordination to ensure that in the future, that a lot of these smart strategies that we don't even know about yet as they're continuing to evolve, constantly as technology does, that, you're not making it cumbersome for owners and developers and tenants and users of the buildings to implement these. So, if you design a building and you try to tell someone, in order to save some energy, you're going to have to rip down your ceilings and rip down your walls, that's going to deter them. So we upfront design in to make these, easily accessible in the future. Similar to that point, there definitely needs to be a synergy between technology and business outcomes. There needs to be a happy medium. And then on the softer side of the benefits, so, the first few were, heavily involved with building operations, energy savings, operational savings, more bottom line issues. And there's a whole softer side to building intelligence as well. And that's sort of empowered and personalized experiences. So, user engagement, user satisfaction, happiness, wellness, health. There's a lot of soft benefits that are great benefits that, are brought to the users of a building through, an intelligent strategy. And then lastly, building systems convergence and coalescence. So, the maximum ability to have, a single converged network, a single highway or communication protocol, that all of your core building systems traditionally, and now as we move into the the IoT, side of things, that they can all speak a common language or protocol. So those are 6 kind of key factors that we see that, what is building intelligence, or the building blocks for it. Just to talk a little bit about the evolution of building intelligence and how we got to where we are today. Starting around, the 1950s or so, we started putting very siloed systems into buildings. So you may have, some basic building automation to control sort of the environment or comfort of a building. You may have had some very basic lighting control system, to control on off, or very rudimentary schedulized lighting control patterns. And they were obviously very proprietary, very standalone, very siloed. There was no communication between systems. We just started to be able to control our built environments. And that was about the 1950s. And to be honest, that stayed pretty, there was advances in the systems themselves and that, but not until sort of the mid to late 90s was there a major switch sort of in the industry. And around the 1997 or so, where the idea of the building sort of converged network came in. So we had all of these traditionally siloed systems in a building that, were each serviced by its own contractor, its own sort of maintenance, its own closed loop system with no interaction. And in 1997 or so, common protocols started, to become popular, whether that was something, if anyone's familiar with, like LawnWorks or Modbus or TCP, sort of the idea of a common language and a common cabling system started to become, apparent, right? Whether that's copper cabling, if you're familiar with, today's standards of, copper Cat 6A or Cat 5, back then in the 90s, it was probably Cat 3. But, so we started standardizing and started moving away from the super proprietariness of these building systems. And that lasted until about, I'd say, 2005-ish, where we started integrating these systems. So the idea of the building dashboard and open protocols and, some level of data exchange or diagnostics between your building systems became apparent. So, there definitely was the introduction of the building converged network. So, the idea of having all your core building systems now residing on the same sort of communication highway. So lighting control, BAS, security, metering, energy management, elevators, all of these individual systems could now reside on the same network, share the same protocol. And, there was the start of data exchange and limited interaction between the systems. And then about a decade later, starting about 2015, so 5 to 7 years ago, is really where that level 4, we call it, or we're talking about intelligence. So we are now extrapolating, immense amounts of data from these systems. We're proactively managing and storing this data, and we're actually analyzing this data. So that's where that intelligence piece comes, where we're learning and we're watching how the building and how the people within buildings behave, and we're starting to predict how they want their building to interact with them. What are the best energy efficiency models to follow? What are the best equipment uptime models to follow? So we're now looking at data and making intelligent decisions and outcomes based on that. And that's kind of where we are now. And that last piece is just really starting to skyrocket into the industry. And we'll talk about that with the introduction of, AI, artificial intelligence, AR, augmented reality, ML, machine learning. This is all pretty much data science. So it's really new, super exciting. And we're just starting to just, touch the tip of the iceberg. So market trends and business drivers, I guess. So there needs to be a reason to invest in any sort of technology, especially when you're, building any sort of environment. So just some of the key factors, around a smart strategy in general, we'll start at the top, is sort of occupant well-being and productivity. There's tons of studies, tons of white papers out there about, how if you have some control over your environment, whether that's comfort through HVAC or your level of lighting, your warmth of lighting, you will be more productive, you will be more efficient when your environment suits your own needs. So that's a large driver of that. And we've all kind of, I don't know if we all have, but there's that sort of classic saying of sort of 330, 300, where, $3 a square foot is spent on lease, $30 a square foot is spent on sort of operations, and $300 a square foot is spent on salaries. So, to keep employees satisfied and efficiently productive, some control over the environment and comfort is absolutely, we've seen it as being paramount. Real-time data is a huge, traditionally you would maybe, pull a report weekly or monthly or even annually in some cases. Now we're pulling, extrapolating data points on a per second basis for some of these systems. The data availability and visibility. So the costs of IP-based storage has definitely come down drastically over the last 10 years or so, to the point where there those barriers of cost to storing data have kind of been mitigated. Climate change, which is a huge part of this presentation in this group, comes to the forefront. And as we look to decarbonize as a way to combat climate change, there's reductions in electrical use, reductions in water use, reductions in gas use. Overall, less densification of buildings. These all lead to, trying to slow down climate change and some of the effects that's going on. Pandemic mitigation, of course. I mean, as we hopefully maybe kind of, crest at this pandemic, there could be more in the future. So, to be better prepared with data on how to handle pandemics in a commercial environment, a retail environment, even a residential environment. Social responsibility and impacts, of course, kind of touches in with climate change. And, no longer is it just a nice to have, it's a must have. And, people are, becoming really passionate about it. Evolving technologies, as with anything, as technology evolves, traditionally in the commercial built environment, it lags behind a little bit. You're going to see technology in your residential, in your homes, you'll see it in your cars. And in the workplace and the business and the retail aspects typically follow, and we're definitely full swing ahead now into the commercial environment as well. Carbon neutrality is a huge aspect right now as well. I mean, most organizations, governments, municipalities are all touching on, carbon goals, whether it's, carbon reduction, net zero by certain dates. So all trying to help combat climate change. Sustainability ties closely with that as well. Future proofing of buildings that we talked about briefly. Government policy as well on how to handle energy, how to handle climate, how to make sure resources are used efficiently. And from even a developer perspective, market differentiation and market presence and leadership. If you're in the business of building buildings, we always laugh when we say, the smartest building is a fully leased building. But, these days, tenants that want to take space are typically looking for, in their RFPs, when they're looking for space, they're looking for smart strategies. They're looking for availability of their data. They're looking for, large control over energy and OpEx and even CapEx to some instance. So by investing in a smart strategy and building intelligence, the developers are really, differentiating themselves in the market. And then from a business perspective, similar to what we just talked about in the market trends, but all of these things, there is a bottom line to putting any technology or spending any dollars in an environment as well. But cost per square foot comes into play. Capital replacement costs or operational replacement costs, maintenance and repairs, employee or tenant attraction, productivity and retention. We briefly touched on infection or pandemic risk, and then obviously business analytics. So, I mean, coupling all of these kind of trends together is what's, leading tenants as well as developers to invest in a smart strategy. So ICT enabling foundation. In order to execute any of this, the building needs to have a minimum level of a communication pathway, or what we'll call an enabling foundation. So, at Mulvey, Banani, and that, we have a pyramid approach to what we see as ICT, information, communication, and technologies. Obviously, starting with, like a typical pyramid, thickest at the bottom is sort of the largest interaction, and as you move up that pyramid, it becomes more and more specialized. So, starting at the bottom there in the blue is your building infrastructure. You need to make sure you're bringing in your service providers with proper, point of presence room, proper spacing, proper rooms, whether that's, MCRs or TRs or LAN rooms, proper spaces and cable infrastructure and your backbone, so that this network can, reside and thrive. The next level at the green point there is your network, and that's your active gear. So, just like any network in your home, if you have a Wi-Fi router or a mini sort of network switch, in all our buildings now these days, we're pretty much putting an advanced, building converged network. So when we talk about the network layer, that's all your access, your distribution switches, your core switches, any of your Wi-Fi, your WAPs, your wireless access points, all your back-end hardware, your servers, your storage, all the equipment and hardware that goes into a network. As you move up to the third level at the orange, so that's your specific workplace devices. That would be computers and laptops and smart devices, tablets, anything that the users bring into the space and use to do their day-to-day business. Above that in the purple is your interoperable layer, and that's where we talked about one step before what we see as true intelligence, and that's where systems can exchange data to have minimal read-write capabilities. They can interpret to some level, but there's no autonomous control at that point. But it may be as simple as a person walks into a room, occupancy sensor picks you up, that means turn on the light and turn on the HVAC. Very rudimentary sort of if-then statements. And then lastly, at the very pinnacle of that pyramid is automate. And that's what we're really getting into when we talk about intelligent buildings, and that's analyzing data, normalizing data sets, looking for outliers to remove, and then constantly keeping that building in a state of continuous commissioning to achieve maximum efficiency, maximum operational benefits, maximum energy reduction, and all the benefits that come across with that. So just to talk a little bit about sort of why we do the building converged network and why it's important. I mean, we talked about having all of these systems, on the same pathway, easy way to exchange data, common cabling system. But realistically, these last four items here, high availability. So we're having network presence on all of these, on all of your floors. You typically have a network switch on a minimum, every third floor to serve the floor above and below. So you do have connectivity throughout the entire building. The third bullet there, security or network security or cyber security, is huge because that's all the rage these days, and so it should be. Most large, that we see are a good chunk of, large cyber breaches are done through building systems, whether that's BAS, whether that's lightning control, whether that's a security camera. Traditionally, these were siloed, sort of unsecure networks that were managed to some extent, but weren't given a lot of thought. And then, those were seen as, ways to compromise and get into buildings. So right now, if you have one solid, robust, redundant, and secure network for all of your systems to reside on, that only brings a benefit to across the entire property. High speed, of course, if you're investing in one solid network for your entire building, then you can run that, fiber horizontally and vertically throughout the building and get those speeds and those bandwidth and that quality of service that you're looking for all of these, new age type systems. Just for a little bit of reference, we're looking at 10 gig backbones as a minimum these days. 40 and some higher, more critical applications. In the not too distant future, we're probably going to be looking at 100 gig backbones with all sorts of different architectures. If anyone's familiar with, we talked about traditional switch-based architecture here. There's GPON, architecture, which is more heavily based in fiber and a little bit less in the active network gear. So there's different architectures to suit different situations. And then PoE, that's power over Ethernet. That will be to some extent the future of powering items. I mean, right now with, high PoE, we're getting anywhere from 30 watts of port to eventually almost probably like 100 watts of port. So that can be all of your laptops, all of your smart devices, all of your lighting will now be powered through that network as well. So, that will change the traditional architecture of buildings. So a little bit about the building intelligence and the pillars. So when Mulvey and Banani, when I think about building intelligence, we see it as 5 specific layers, each one building on the one below it. We're going to touch on these further in breakout slides, but layer 1 is priming or digital enablement. So that would be getting your system or your building systems ready to be part of a smart strategy. Layer 2 is integration and data. That would be pulling in data from the systems. Layer 3 is visualization. Layer 4 is analytics, and layer 5 or above would be specific applications, which we'll touch on. The first pillar, so layer 1 systems priming, or what we call digital enablement, and like I touched on it earlier, that's almost the minimum level of smart design or building intelligence engineering that we're doing these days, and that's getting a building ready to accept the future smart strategy without having to rip it apart. So that's heavy upfront engineering work. So that's where we are coordinating with all our other consulting partners on the team, whether it's mechanical, electrical, ICT, security, even architectural and structural to some extent. And we are influencing their documents. So we are having them specify all of their systems, all of their devices, hardware, software, integration level, to ensure that they are in line with the smart strategy, that the data the client needs in the future will be available and tagged and identified and using proper ontologies. So pretty much future-proofing the building. Layer 2 is integration and normalization. So that's taking the smart strategy one step further. So now I have a building that's smart capable, but now I'm actually going to start extrapolating data. So I'm going to start pulling data from all of these building systems and all of these IoT-based sensors and IP-based systems, so that we can normalize the data and we can start storing it, whether you have a data lake or just any sort of normal network attached storage or storage medium. So we're actually now extrapolating data from the building so that it's ready for use. Layer 3 is visualization. So you may have heard some of the single pane of glass or UUI, unified user interface, or an IBMP, integrated building management platform, or even a digital twin to some extent these days. And realistically, after we've made the data available, we've extrapolated the data. Now we're visualizing it. So you could just see some examples of what a single pane of glass or a touchscreen control would look like, whether it's 3D renderings, whether it's just 2D CAD floor plans, Google Earth Maps, satellite. There's various different renditions on how this can look, but essentially it's visualizing your building's data. And sort of that definition of a digital twin, which would be sort of a digital representation of a physical asset. So if I take enough data points from all the various systems of a building, theoretically, in the digital world, I can create a twin of that building, and I can test different things, see how the building will react, tweak all the different systems in theory before I do it in a real building, so that I can realize the maximum efficiencies before deploying anything. So that layer is a really handy layer in the overall smart strategy. Layer 4, analytics, and this is where we started talking about the intelligence. So you may have heard of, modules called fault detection and diagnostics, which heavily comes from the BAS and HVAC world, where it's pretty much rules-based analytics. If this, then that. So, if the system isn't heating, then you should definitely not be cooling. So we're looking for anything that could be, offsetting. So very rudimentary ways, but to save tons of energy. And you wouldn't believe, just over time, how set points change and, items just lose their efficiencies because we're not checking the data to make sure that they're in that original state of commissioned efficiency. So on top of that, we talked about machine learning and artificial intelligence as well. So the idea of machine learning is that we are looking at the data and we're constantly looking at it. And when we see enough of a commonality, then you can autonomously make that the norm. So a very simple example would be, I come into my office every morning I turn on my lights and I immediately dim it down to 60% because A, I want to save energy, and B, that's the light level I like it at. Well, on the 10th day of that exact, performance being done, next time I turn on my light, it automatically goes to 60%, just because it's seen that action, it's machined, it's learned that action, and now it's proactively taken an autonomous approach to make my day easier and just started at 60%. So that's a very basic example, but that's what we talk about when we talk about machine learning. And there's all kinds of reports and metrics in that, which you can see in this quick little snapshot here on how to display, your savings, your analytics, how much carbon you're offsetting, how much water you're saving, electricity you're saving. The sky's the limit on these customizable sort of GUIs. And then lastly, we talked about application-specific intelligence, whether, you could be talking about retail or commercial or residential, or even further, if you talk about clinical in an acute healthcare environment, institutional, transportation in terms of airline transportation, very specific subsets of systems, which are very specialized, but again, large opportunities for building intelligence and savings and operational efficiencies. So just to touch on some sample use cases, and when we say use case, there needs to be a reason to do something. So, in order to invest any sort of capital or time in a building, you need to be getting something out. So the use case, typically when we sit down with a client, we have to say, what are your goals? They could be to save energy, everything we talked about. They could be to attract and retain employees and staff. They could be for user engagement and satisfaction. And then we start to look at the building, the specific systems involved, and how we can attain those goals with technology. So, when this sort of whole industry started, everyone just jumped into, let's get as much data as we can, and then we'll figure out what to do with it. And, the industry has now stepped back to say, well, let's figure out exactly what we want to do first, and then go get only the data that we need. Just because, it just becomes unbearable to store and manage millions and millions of data points without a clear, end goal in mind. So these are just some high level kind of use cases that we've been deploying on a lot of our projects across the board, which we're seeing real savings. We can report on, the ROIs and the KPIs, the CapEx, the OpEx costs involved, if there is, client satisfaction and so on. So we talked about, building system digital enablement, data ontology, the whole aspect of people counting and occupancy-based system control. Leak detection to some extent can be super proactive in avoiding major downtime, and we'll touch on that. Multi-head sensors are kind of cresting right now in the industry and super important for environmental data that you typically wouldn't get from some of your core building systems. And then like we said, the integrating building management portal, or that visualization layer, then the analytics layer, and then of course building experience mobile applications are huge right now. We'll touch on that, and that's controlling your environment through your phone essentially. So we touched on digital enablement, so I'm not going to belabor that a little bit here, but again, we are future-proofing all the systems and making sure they are ready to accept a smart strategy. Data ontology. So this may be a little bit technical, or it may not seem as important as it is, but it's probably one of the most important aspects when you're designing a smart building. So like we said, if we're going to be ingesting thousands or, to some extent, even millions of data points over time from various systems and various buildings and various locations on various floors, each data point needs to be correctly conventioned, tagged, and stored so that they can be referenced in the future. You can't have any duplication. You can't have any misspellings. You can't have any ambiguity as to that data point that you need. So there are industry standard sort of ontologies, some of them here, if you've heard of Haystack or Brick Schema or Real Estate Core, where all of your data can be tagged, conventioned, and stored properly. Super important. People counting, we touched on, and there's various different people counters. You can use thermal-based, you can use camera-based, you can use radar-based. Various different use cases will have different applications, but the idea of occupancy-based systems or occupancy-based usage is where we're going to see a lot of the savings when we talk about energy savings. So traditionally, every building in the world to some extent would fire up all its systems. Theoretically, let's call it 6 a.m. They'd run on a typical schedule until 6 p.m. until most people go home, and then after hours could be done differently. But you're pretty much heating or cooling or lighting an entire building for an entire set of time, regardless of who's there, how many people are there, and all the environmental usage-based items. So right now, we're really using people counters to see how many people are in different areas of the building, and we're only heating or cooling to satisfy the location and quantity of people in certain areas, certain spaces, and then the sky's the limit. Then we're using that information to do janitorial servicing, dynamic washrooms. So, traditionally you would just, you would clean every washroom in every building every night at 8 p.m. Well, you know what? Now, especially with hybrid work models, you can see which washrooms have been used, which washrooms, which haven't, and theoretically, clean, which are using chemical type products, using energy, using labor hours, and you can drastically cut all of these operations in half, if not more, in some extent, if you know how your building's being used. Also, with people counting, the idea of space usage and utilization data, from a tenant or a developer side is super important as well. So, if you've designed your space and you're a tenant and you could see how many people are using certain boardrooms, how many people are using your amenities, your yoga room or your gym or your conference room, and it really sheds light on how spaces are being used, where we can tighten up and densify, to take less square footage. So overall using less energy and less resources, invaluable information across the board. Leak detection. So that, in any mechanical system, there's always going to be obviously some aspect of leak detection. But when you talk about enhanced leak detection and you're looking for sort of micro leaks, which over time can save tons of water, and whether you're looking at volume loss, pressure loss, sort of any sort of even temperature-based data can come back from your water sources and really avoid catastrophic leaks, which can take down buildings or floors for months. Which we see regularly in the consulting world. You could save tons of money on even insurance premiums, showing insurers that you do have an added level of leak protection, and reduced maintenance and repair and diagnostics. So you can easily see where you could be potentially losing water. And on the buildings wide or portfolio wide, you could save tons of water by mitigating small leaks throughout the buildings. Multi-head sensors, which I think are one of the most important items right now for building intelligence. This is just an example of one right here, but it's a single sensor, which we're either putting into light fixtures or standalone sensors if we want to get a little bit more data. But we're looking at light sensors, inbuilt analytics, motion detection, ventilation, temperature, humidity, air quality, audio quality. So all of this data you can get throughout spaces using these multi-head sensors for an array of these, use cases that we're talking about, right? Invaluable data. This specific sensor I actually put throughout our office as well. Perfect example of the use cases. We have a games room in our office right now, and we were getting some staff saying, complaining that sometimes that game room gets loud. So right away, we go to our multi-head sensor, we can see the exact audio levels in terms of dBs at different times of the day, and we can tweak how to operate that room so that, everyone can work and continue their productivity. Small use case, but, it's just a quick example of having data throughout your space is, solving tons of problems. So the IBMP, or the Integrated Building Management Portal, and that visualization layer right now, I mean, if you are going to jump into a building, an intelligent building and a smart strategy, you need to be able to visualize your data. So you need to have a dashboard. That dashboard can be used by your operational team. It can be used to, show staff, all the different initiatives we're doing to, be sustainable and decarbonized. It can be used for visitors. It can be used for wayfinding and general use, fully customizable. So, if you have a whole data set, you can't really do anything unless you can visualize it and control and manage that data. So there's tons of vendors, manufacturers, platforms that are specializing in this and that, and that's only continuing to grow over time. Fault detection and diagnostics, analytics, and machine learning, we talked on that again, but typically a different module, and pretty much with any sort of technology, right now there's vendors who do all of these individual things very well. And as the industry matures, people will ingest other companies, and you're going to get that holistic, we do everything sort of mentality. We're still at the stage right now where we can select and choose, due to the reduction in proprietariness, the increase on common data ontologies and common protocols, that we can pick and choose the best module for FDD, the best module for machine learning, the best module for IBMP, and we can engineer and piece together a perfect, as close as we can get to perfect customized smart strategy based on the client's needs, the building, and who interacts with it. And then lastly, and some of the most exciting use cases right now are on building experience mobile applications. We're primarily seeing that on the residential side as well as the commercial side, and that's essentially getting a specifically branded, so a white labeled mobile application that you can download from Google Play or the iOS store, specific for your building, where you can, let's say in a residential market, you can control your lights, control your HVAC, so your Ecobee or your Nest. It's your security card now to get throughout the building. You can pay your rent. You can control your EV charging in the underground. You can order your food and your Uber Eats and all that good stuff through deep links. So it's pretty much a one-stop shop to completely function in your building. Everything from wayfinding and visitor management and room booking and catering and that on the commercial side, workplace, management and communication and socialization. Is all being brought together through mobile applications, pretty much like everything else. And that's been a really large advancement in the industry for sure. So we talked about all these pieces. So just from a sort of engineering high-level architecture, this is what we would be looking at here, right? So in the center, you have your building converged network, which we talked about. And here you have all your core building systems that are now IP-based. So they are connecting to these network switches right here throughout the building. And we talk about security, BAS, lighting control, metering, elevators, so on. Coupled with your core building systems, you also have all your IoT-based sensors, right? So you can have, additional indoor air quality sensors, occupancy sensors, people counters, multi-head sensors, also all IP-based, terminating on that same common network. Then coming out of that network, you're going to have that data normalization or aggregation layer. So we're extrapolating all this data and normalizing it, getting it ready for use. Then we need to be able to visualize it, which we talked about through, that IBMP, / digital twin sort of, visual layer. We're running our analytics on top of that data, and then we're having our outputs, right? So whether that's to a mobile application, to a work order management system like a CMMS or an energy management system, so all of that data is being analyzed and then influencing the whole operation of the building. So KPIs and ROIs, I guess, so key performing indexes or return on investment. We're starting to right now get a lot of feedback on actual real life benefits to this, whether that's, people's perception, which you can see in the market trends, right? 74% of architects and building owners, they truly value green and healthy buildings. And it's not just about getting a lead point anymore, and that there's an actual, real big move to help mitigate climate change. 48% of new builds in the US are expected to be high performance. 95% of tenants would prefer to occupy green buildings. 90% of millennials, which by today I think is 18 to 34, but they truly do value working in a sustainable company. So the softer side of the people effect that's driving sustainability, driving decarbonization, which is leading to a reduction in climate change, is what's driving this. And then from the building owner's perspective, your paybacks on energy savings, operational savings, and efficiencies, we're seeing it 2 to 5 years. And traditionally, anything 7 years and below is almost a no-brainer in terms of investing in that. So from a business perspective, as well as a sustainable and technology perspective, it's a win. It truly is becoming a win-win, and that's why it's just only growing and growing and growing. From a suite intelligence on the residential side as well, you can see that there's a lot. I mean, we won't go through every single point here, but there's a huge push from the tenants who are in these purpose-built rentals right now, that they want a smart building, they want a connected building, they want to be able to control everything from their phone, single touch, minimal interaction. the demand is there. So the user engagement is high with a mobile application. We're looking at 60% plus, you know, in a purpose-built rental that people are interacting and using their mobile application to, you know, navigate their building. We're seeing on a residential side, 12 to 26% energy savings due to, you know, controlling thermostats on specific schedules, 40% savings related to maintenance and water damage. And again, 2 to 4 years payback. So, and lastly, really to drive it home, we're seeing, you know, in a legacy type building, so a building that's, you know, been built for a while with, you know, less efficient systems over time, you could see up to 50% energy savings, you know, if you are retrofitting these systems to be IP-based, to be modern, and to, you know, incorporate some of these items we just talked about. But realistically, in a new greenfield site, we're seeing 15 to 20% energy savings, depending on how far you want to take this smart strategy. The value of real estate themselves and premiums on rent and other sort of, you know, lease rates can be, you know, 30% and above, depending on how important technology and sustainability and some of these use cases are. But, you know, there's hard facts now to show that. From an occupant level, you know, 60% improvement in comfort, which can lead to almost, in some instances, a 90% improvement in health and well-being, just by being able to control and properly monitor and have the right environment for people to be in. And then from an energy and a carbon footprint, 20 to 50% reduction in energy, that, you know, depending on the building, the type, the area you live in the world, up to 25% reduction in utilities costs, bottom line, electrical, water, gas, up to 10% reduction in water, 40% reduction in carbon emissions can also be achieved. So, you know, when we talk about decarbonization, there's so many factors here. This is just one. You know, building intelligence is one where if we can bring down our energy, you know, all the carbon that's needed to create that energy, that electricity is then saved. But so the whole built environment is moving towards electrification. So getting rid of gas for heating and cooling and going to more air sourced heat pumps, which are electrical based. So once things are electrical, we can control them. And when you can control them, you can, you know, bring in that occupancy based control to really reduce, you know, your carbon emissions up to 40%. O&M, so 30% less maintenance time, less diagnostics time. Right now, if there is an issue, you can pinpoint that and you're not crawling around the building for a day or two to try to figure out what's wrong. And then on the suite intelligence side, just satisfaction, you know, ease of use, being able to control your building and your environment from your hand, which leads to higher rents, which leads to, you know, a win-win for everybody again. So, you know, that was just a high level overview of what building intelligence is, how we got to where we are, and, you know, what we're doing in buildings these days and where the future is going. And then obviously some of those ROIs and reasons that people are doing this. So I guess I'll pass it over to Jim.
That'll be me, Mike.
Oh, sorry.
No worries.
Sorry.
Yeah, thank you so much. What a great presentation of building intelligence implementation. I just really appreciate you introducing the building intelligence technology from 5 different levels, you know, from the fundamental level and to the really, really high technical level. Just really appreciate that.
Yeah, and to be honest, I mean, this is just very high level, touching that tip of that iceberg on you know, how deep you can get into all of these subjects. And you know, you could almost speak an hour or two to each one of these items if you really wanted to get into it.
Yeah, now we've collected a handful of questions on Slido. I guess we could take a look at those questions together. I'm going to start sharing my screen.
For sure.
Okay. Perfect. So the top rated questions, the first one would be, I'm wondering if you will share the recording with participants later. I guess I can answer that. Yes, so the recording of this video as well as the presentation slides will be posted on PEO East Toronto chapter website. So you will be able to find all the information on the website. Perfect, then I'm going to archive that. The second question is to Mike. What are solutions for, okay, so people just start voting on the questions that I'm most interested in. So the top rated question is, what occupancy sensor do you recommend for commercial office buildings?
So you know what, I mean, traditionally in a commercial office building environment, occupancy sensors were, part of the lighting control system. And those lighting control systems, were and still are to some extent a little bit proprietary, right? I mean, typically today they are DALI based and some of them are POE based. So, and they are still unique to the system, right? So you could be talking about Incilium or Fifth Light or Lutron. They're all going to have their very own specific occupancy sensor. But when we talk about intelligent buildings, then you can pull out, anything specific to a system, and we can talk about sort of that multi-head sensor, right? Where, not only am I just using, occupancy or vacancy, actually is quite the opposite. We're looking for vacancy as opposed to occupancy in order to shut off certain systems. And, there's a handful of manufacturers that do it very well. Everyone from Delta to Xandar to some others will definitely do occupancy very well.
Great. Thank you. Second threaded question is, what are the solutions for existing buildings with obsolete systems, such as a rooftop air handling unit that only has on-off control?
For sure, and this is a big part of what we do from a building intelligence engineering consulting world, is that we go in and we do sort of a building intelligence readiness assessment or feasibility study. So we go in and we crawl around a building from top to bottom, and we see the current state of all those systems. So right here, if we're talking about an AHU, even if the legacy equipment itself, we're more interested in the controls of that equipment, right? So in some cases, if the solution is too legacy based, it's too old, there's nothing you can really do but sort of retrofit that system. But there are a lot of control mechanisms that you can put in place, sort of middlewares or gateways that you could still extrapolate some data from these systems, whether it's just on off or a control sequence or schedule sequence, which can allow you to do some of these use cases to some extent. So that's usually what we're looking for, is not necessarily the hard piece of equipment itself, like an AHU, but how we control that AHU using data.
That makes sense. So are you suggesting that the obsolete systems might not need to be overhauled for?
Well, that's the benefit, and each project will be unique, and each state of that equipment will need to be investigated. But that's definitely the goal, is that, like we said, by future-proofing a lot of this stuff, you won't have to go and overhaul and replace major pieces of equipment in order to introduce some sort of a smart strategy in the future. If we're looking at buildings from the 70s and the 60s right now, sometimes there is little that can be done without a major overhaul. But, anything that's reasonably modern can usually be augmented and, brought into today's world with a control mechanism.
Nice. That's good to know. Thank you. This question is from Ben Russell. Have you seen a one-stop mobile app that actually does everything?
What great question. So there's two thoughts to mobile applications right now. There's off-the-shelf mobile applications, which companies do it well. It's kind of canned. You can do X, Y, Z, and they do it well. And that's it. Some examples could be, if anyone's familiar with like VTS, they have a Rise app and a Lane app. More residential and commercial based. You can have Comfy, or you can have HQO, and there's a lot of off-the-shelf mobile applications that do a lot. And then you can go the other way, where if you have some very specific use cases, some very critical niche markets where you can have an app developed. There's pros and cons to both. There's app upkeep, there's development charge, firmware updates, all that good stuff that you have to, kind of stay with if you're going customized. But a one-stop off the shelf, like some of the ones I just named, can do a lot of stuff, and they do it well, and they do it, fairly easily.
Nice. So is this goal to have one-stop platform that controls all multiple systems?
And that's where the industry, when we talk about building intelligence, started, is that we said, okay, let's do all these great things. And then we started having a different application to do every little thing. And then, you got stuck with where we were at the beginning with 10 different systems. But now, so we definitely do see benefits in tying it all together. Now, that doesn't necessarily mean you want to actually use SDKs and, open REST APIs and truly write integrations to everything. We can use these apps and just have deep links in that to other apps, right? So that you are in one user interface, but you are, accessing multiple different apps at once, but the experience is consistent.
Nice. Thank you. what are the main technological challenges and headaches when implementing BI in a building?
Overall, I think it's just coordination, coordination with all the other, and it's not that it's a challenge or a headache, it's just that coordination, that upfront design and engineering needs to be done meticulously in order to get the data that you need, get it in the format and the ontology that you need, and in the protocol that you need so that these systems can exchange data and use them. So I think just, during the upfront early days of the design, really understanding the client's needs, what their goals and outcomes are, very important, what their budget is, their, day one and day two budget. A lot of times day two, like operational budgets, are overlooked during a capital project, but, they really need to be considered now because, as more and more of all these, intelligent technologies, they're all SLA based, right? They're all SaaS based. They all have a day two cost to continue and maintain them. So, just planning out the design and, where the building and the owner wants to be in 2 and 3 and 5 years needs to be taken into account now. So just, getting a clear roadmap, I think is one of the challenges.
Great, thank you. Next one, how would traditional engineers be capable of using BI technologies to reduce climate change impact? Any suggestions for skill set building?
Yeah, so I think everything that we touched on right now. So, I mean, my background is, my actual major was electromechanical engineering, which, is perfect for we're touching all electrical, electronic, as well as mechanical aspects in order to control those systems. But, networking is definitely a skill set to understand, active networks, fiber backbones, converged building networks. And then the idea of a building intelligence engineer is continuing to evolve. And with my team, we always laugh is that, there's a new system that we need to become experts in almost every few months, right? Whether that's people counting, whether that's real time, RTLS and, asset tracking or, Bluetooth beaconing or, any advancement in technology, we're becoming experts in that. So, it's really just a love of technology and a passion to continue evolving as the industry evolves. So specific skill sets, I mean, analytical thinking, forward thinking for sure. Any sort of engineering background will help with that for sure. But you learn as the industry advances, I think, just like with most things.
That makes sense. Do you think programming skills, learn how to use artificial intelligence to train your
in my opinion, that's definitely where the industry in the future is going, is the whole artificial intelligence and machine learning and, having predefined analytics, review data and, have actionable outcomes. So, to understand from, and it all depends where you're going to play in the whole building intelligence market. Like, so I'm in consulting, so I'm in, more construction based, like let's actually build it. But for every product that we use, there's tons of R&D and computer programmers and software engineers and network cybersecurity specialists. So, wherever your passion is, you can definitely fit into, this common goal of intelligence, sustainability, decarbonization, climate change, mitigation.
Nice. Moving to the next one. What is the most challenging ICT enabling foundation to establish in existing buildings?
In existing buildings, to be honest, so you're definitely going to want to establish at least some semblance of that building converged network. So you're going to have to find ideally stacked risers, which in an existing building are few and far between. They're usually full of junk over the last 20, 30 years, or they're not stacked, they're all offset. So, finding the right spaces to host a building converged network can be challenging. And then obviously, if you're putting it into an existing legacy building, most of those systems are legacy as well, and they're likely not natively IP based. So you might need to apply some, gateways or even middlewares to get those systems onto the network. So, and then lastly, to run all of that copper cabling out to those network devices in existing ceilings and existing wall types can be a challenge.
Yeah, I'm just thinking of like large warehouses. It could be 1 million square feet, and from one end to the other end, there would be a lot of upfront costs to establish that network.
Oh, no, absolutely. And in traditional copper cabling networks, you are, confined to some distance limitations due to the cable, right? So typically you're 90 meters maximum distance from device to, let's call it network switch termination, including all your patching and that. So, in certain areas, you're definitely going to be over length because you can't run everything perfectly perpendicular every time. So you might need to introduce, mediums to be able to extend copper or convert fiber to, copper and different measures that, individual engineered solutions will require.
Yeah, that makes sense. We are just hitting the time limit here for the Q&A, but I want to remind everyone that there is a networking and Q&A session at the end of the seminar. We will be answering those questions posted on Slido. So keep posting questions. We'll have time at the end of the seminar to answer them. Now I will pass it to Sana.
Thank you so much, P.Eng. And Mike, thank you. That was an awesome presentation. I think I'm off mute. Yes, I am. Okay. Yeah, that was an awesome presentation. Definitely learned a lot about building intelligence. That was actually phenomenal. Learned actually a lot of stuff that I wasn't even aware of. So I really appreciate all the details that you went through and all the great steps that you kind of listed throughout the process of this presentation. On behalf of the Ottawa chapter, because I'm the chair, I would like to thank you, and on behalf of all the chapters that sponsored this event and all the organizers and the audience, the amazing audience that always show up and support us. We truly like to thank you for the phenomenal presentation. From the bottom of our hearts, we've learned a lot, and we really appreciate all the work that you've put into this. So thank you so much, and I'll keep it short and sweet so we can give some people time to ask any questions that they have in mind or possibly network. So thank you. And Chris, are you on the line, Christopher?
I'm here. Thank you very much.
Amazing. All right, on to you. Thank you.
All righty. Good evening, everyone. And thank you once again, Mike Prsa, for an insightful seminar. I want to start by retelling everyone, engineers, we're mandated to protect the public welfare with our engineering. And now more than ever, the world is looking at engineers to address the climate action issues. We've gone from pre-industrial era to the fossil fuel era. Now we're striving to get to the sustainability era, and intelligence technology is going to play a key role. With the information and expertise we received today, we're one step closer to getting to that sustainability motion. You see, we're not all in the same boat. We're all in the same storm. And we each have to recognize our individual capabilities and maximize the value from building intelligence and decarbonization. Today, we check the weather forecast, temperature, humidex, but it's only a matter of time when we start getting reports on air quality. If we're going to be spending more or less time in buildings, then now is the time to make these BI changes. Over the last 5 years, we've started shifting to a culture where we need things now. We want things instantaneous. We want them yesterday. And since COVID-19, we accelerated into a digital and electronic subset towards the sustainable era. So it's my hope that you have enjoyed and learned from Mike Prsa's seminar, and we'll adopt some new perspectives as engineers in improving the public welfare, looking at climate change and climate action in a different way, and using what we learned today about building intelligence and working towards decarbonization. Thank you again for joining us today, and I'll be passing it on to Jim for final remarks. Thanks.
Thanks, Christopher, and thank you, Michael, and all the volunteers that made this seminar possible. This happens to be the 12th seminar that our group, the Ad Hoc Climate Change Group, has organized since November 25th, 2019. And this purpose is to give a chance, mostly to PEO members, but others, to learn about climate change and to hopefully embrace it. But one of the key purposes as well is to put the climate change issue on the radar of the PEO. And, it's a bit of a process, but I do believe we're getting there. Last week, a motion from the Councillors Committee that Christopher happens to chair is moving forward with a motion to leaders of the PEO dealing with climate change. And I'm very optimistic that it's going to stimulate a good debate among chapter leaders. And the request that a guideline be developed by the PEO, I do believe will be supported by that group. And that's going to stimulate a further discussion within the leadership of the PEO And hopefully it's a first step on the way to developing a climate action plan for the PEO. But it takes effort. And part of that effort is that the group I just mentioned. And there will be a survey at the end of this meeting asking various questions, but there will be two, and I encourage you to particularly look at those. One is, are you interested in taking part in the ad hoc climate change group? If you are, please add your email. And there's also another question regarding the two Toastmasters clubs, engineering-based Toastmasters club, that help sponsor this committee. So if you're interested in being invited as a guest to either one of those Toastmaster clubs, also leave your email. So thanks again, everybody, and I'm going to officially adjourn the meeting. But as indicated, there's an unofficial networking session that will happen immediately. I'm going to turn it over to P.Eng to lead that. P.Eng? P.Eng? You're muted, P.Eng.
Oh, sorry. Happens all the time. Thank you, Jim. So let's pick up these questions on Slido. Like we get more questions coming in as 5 minutes ago. So you want to jump right into the questions?
Yeah, for sure. If you don't mind, I can just start tackling them in sort of order. So, I mean, in terms of BI technologies, do you think North America is behind? Hold on, let me move this. Behind European countries as they really take net zero goals so serious compared to North America? And to be honest, I think when I started sort of the building intelligence engineering division at Mulvey, maybe 7 years ago or so, I think we were slightly behind. I think a lot of the forward-thinking technologies that work you're seeing in London and you're seeing in Cyprus and you're seeing in Belgium and Netherlands. But to be honest, over the last 3, 4, 5 years, I think North America has really taken leaps and bounds. Toronto and specifically, I'm super proud of, and they're really taking building intelligence seriously because they're seeing the benefits. And now it's not just let's talk about it. It's not smoke and mirrors. You can see the tangible benefits. So we may have started slightly behind, but I think we caught up pretty quickly.
Nice, thank you. Let's archive this one.
Which cloud service do you think is most suitable for this BI, AWS or Azure, or IBM? And to be honest, it all depends on the client. I mean, a lot of clients, in their data privacy and their data management, protocols and guidelines and standards. I mean, it all depends on whether you need data to stay in Canada essentially, or whether you're okay with it leaving. And to be honest, all the major data centers now are setting up shop in Canada as well, whether it's AWS, whether it's Google, Azure, Microsoft. You're seeing data centers in Toronto, Montreal, Vancouver, all your major hubs, so that everyone does have the full suite of options for what serves them better. So I don't think any specific one is best for BI. We've used them all.
Okay.
What might be the consequences if the system fails for any reason, like we had a Rogers outage recently, if that happens to the system? Great question as well. And that's one of the biggest reasons to have that robust building converged network is that, you can build in your resiliency and your redundancy and your fail safes. So whether that's, redundant fiber runs or dual power supplies on your network gear, or, alternating, multiple risers to have, physical as well as, virtual diversity. So I think, we're building in a lot of the fail safes, but the thing is, building intelligence itself, if the system were to completely fail, I mean, you're just going to lose sort of that data analytics. You're going to lose that visualization. So the building will continue to run as, all these systems are still managed by their own server and their own system to some extent, right? This is a last layer that sits on top and ties it all together. So I can't see major consequences. Besides, some loss of data, which typically continues to get recorded locally and then gets downloaded as soon as the network comes back anyways.
Perfect, thank you.
Are HVAC mechanics technicians currently ready to maintain such sophisticated systems? Great question. So we're seeing, from the contractor side, coming at it from two angles. And one is the traditional, BAS controls world, so your HVAC mechanics, your technicians. And the other side is from your sort of ICT world, so your networking world. And with, especially in the built commercial and retail environment, There's always a learning curve. If we take, electronic security, for example, the entire industry switched from analog to IP-based, security systems, let's say well over a decade ago, but there's definitely a learning curve between, the R&D engineers that develop the technology, then to the consulting world that learns how to implement that into construction in the built environment. And then lastly, once there becomes a demand and a need, and it gets down to the contracting level to install it, then of course there's a learning curve too, for the technicians to get updated certifications, updated training, whatever they need to properly do these systems. And to be honest, when we started in this industry, like I said, 5 to 7 years ago, that there definitely was a little bit of a bottleneck on what we call, these days, the MTI, or the Master Technology Integrator, which is, the person or the company that is what we see as, deploying the building intelligence solutions.
Thank you.
Is there any particular building material that you would recommend to clients to allow for a BI system to be optimized? So we're looking at concrete, steel, mass timber. And to be honest, no, not particularly, because I mean, everything is pretty much, based on either wireless or based on, cable and conduit or some sort of cable trace. So I mean, in terms of running the infrastructure, we're doing tons of mass timber these days as well. There's, a lot of benefits for that, and concrete and steel have been around as your two major, structural elements for the longest time. So, it's just in general, nothing specific to BI. I think just whatever is most conducive to running infrastructure, whether that's conduit, whether that's cable tray, whether that's J hooks, whatever you're using to, sort of, hold your system together. But I wouldn't see any specific benefit or downfall to either.
Great, thank you.
What do you see the future of building intelligence implementation in the next 10 years? I'd say in the next 10 years, it's going to become commonplace that, these systems will all be IP based. We're going to start, extrapolating data from all these systems. That'll just become a commodity, and that'll just become normal, just like lighting control, just like BAS control has over the last 20, 30 years. Where I see this really going is on that analytics side and that sort of deep machine learning and autonomous control, where the building will recognize how it needs to operate most efficiently and do that itself. So you're going to move more to a NOC environment, a network operations center, which we're already doing for some clients now, where you almost have a mini command center, and a few individuals in a NOC are now managing and operating 30 buildings across the country, and they're all doing it remotely by VPNing into the sites, making tweaks, and then you may have some boots on the ground and in each city that, should you need, you go to that building. So I really think that that's the way the industry is going.
Perfect, thank you.
How mature is the industry, and who are the major players? So like I said, I mean, the rumblings, I'd say, started maybe even, as early as, 8, 9 years ago. It's really matured, I'd say, over the last 5 years though. Major players, I mean, there's players at all levels. There's players from a design and engineering level. There's players from the contractor level. There's players from the vendor level. So, we could touch on all of those players, but that's a huge list. So there's definitely people that are now becoming specialized. Like I said, they're advertising and marketing themselves as MTIs or MSIs, master system integrators. This is what we do. We're the building intelligence contractor. So and those are usually spinning out of your major mechanical firms, your major electrical and IT firms.
Great, thank you. This one jump to the top.
Do you think governments would ever make BI mandatory? You know what? I don't know if it would ever be mandatory. And I mean, it's funny. I sit on the executive, the CSA executive committee for building intelligence standards. So, I don't think anything would be mandatory, but I think climate and ESG and that may, influence a lot of this, and it does influence it. So, hitting energy targets and hitting decarbonization goals and net zero goals, and that, that may become not mandatory, but, recommended and suggested, and individual organizations are making it mandatory and policing themselves actually, which is great. So, before the government would step in, I think, it's being tackled at the local level first.
Great, thanks.
Is there any reference for this KPI value? I mean, how these KPI values are estimated? Yeah, absolutely. So, I mean, that's not just values we've taken out of the air. We've pulled and consolidated data from many different, articles, R&D, white papers. So, we can maybe as a sidebar give you sort of the where we pulled all of that information from, for sure.
Thank you very much. Next one.
What components of the BI solution would you consider to be highly reusable, and what components need to be tailored and configured for the specific building? So I think, your foundational element of your building conversion network is somewhat of a commodity. I mean, you can install it and find it at many different levels, whether you're talking, full end-to-end Cisco, or, if you're looking at Aruba or any of these other solutions. They're very standardized and can be reused and so on. You're getting into tailored and specific configurations, usually at your different, your vertical as well as your asset class. So, commercial will be different from residential, will be different from retail, will be different from institutional at that level. And then it'll also be different based on your asset class. Are you a AAA office tower in, a major urban environment, or are you, more of a suburban, A-class? So where you want to be on the price spectrum and who your sort of target audience is kind of, tailoring the solutions, I think.
All right, thank you very much.
For cloud-based IoT solutions, who owns the data that has been collected? The person building that is generating the data, or the cloud-based IoT company? I mean, great question. And that's kind of a debate that's gone on for a while. And that's kind of between the data generator and the data center themselves, and sort of whatever, terms they come to. But typically, I mean, obviously it's being mandated that, we're using a data center to store data and manage data and secure data, not to leverage and, have some sort of data sharing. So typically whoever produces the data is owning the data. And that's definitely the ideal solution.
Great, thank you.
How much energy could BI help to save comparing to a traditional building without BI? So we touched on that. And on a new build, like a greenfield, let's say commercial tower right now, where all of our systems and all the individual building systems are, super efficient, and that out the gate, just based on modern technology, we're seeing, 12 to 15, up to 20% savings on energy. On our more legacy type buildings with more inefficient systems, and if we apply a higher level of control and some of these BI measurements, we're seeing, like we said, 40% and above potential savings on energy, depending on how much you invest and what applications you're using.
That's significant.
It's super significant.
Great presentation.
There you go. Great question. This has been a long time evolving because the costs of retrofitting are key to the building lifespan. Landlords are reluctant to spend, and it's true. And that's why you have to understand the landlords and developers. I mean, they're running a business too, right? They have a bottom line, and you always would love to be as sustainable and as climate conscious as you can be, but you also have other business goals in mind too. So now that we're actually seeing hard, measurable benefits in terms of dollars, operational savings, energy savings, and all of these benefits, it's really motivating, the developers and the landlords to spend as well. And you truly are getting that win-win situation.
And as you mentioned, with all the analysis in ROI, it would definitely help the landlord to make a decision.
And you know what? I mean, we saw the industry, especially because the capital costs as every technology, capital costs come down with time, right? Only the latest and the greatest technology is really bleeding edge. But now we're getting the metrics back, and you know what? If there is money to be saved, then they're going to spend on it, and it makes sense. The paybacks are there.
Yeah. Two more questions to go.
You did not highlight the benefits to maintenance or the degree of individual environmental controls operated by the workers. Can you comment? So we did touch on, I think, the benefits to the maintenance on, saving on diagnostics times, saving on catastrophic failure, savings on long lead time equipment where you can proactively, have a proactive maintenance and kind of target and have your maintenance and upkeep scheduled, right? So, if I'm ingesting data from all of my systems, and for example, if I know this LED lamp has 50,000, hour life, and I'm monitoring all this data, and I know we're on, hour 45,000, it's time to preemptively, order and potentially start relamping. So, it allows, you know, a system and a management and a maintenance program to be followed properly so that you can, you know, use items to their max without them failing and causing large disruptions. Actually, just to add that too. So the idea of a CMMS, or a sort of, you know, computerized maintenance management system, whether that's, you know, a Yardi or an Angus or something like that, you know, a lot of those are now integrated to the IBMP, or that visualization layer, so that you can automatically generate work orders, you know, based on the data coming back from the systems. Like so to use that lighting example, is that if I know a lamp is about to burn out, I'm integrated to my CMMS. So I'm automatically creating a work order to say, you know what, we need to start relamping this floor because in the next 3 weeks, the lamps are going to start failing. So it's just creating a smoother, continuous, you know, avenue to operate the building.
Absolutely. Thank you.
Do you anticipate the IP devices on a converged network being segregated between multiple VLANs or all residing on a common LAN? Great question. And you know what, the industry's flip-flopped on this to begin with. So, you know, typically for super critical and, you know, installations, if it's banks or if it's, you know, a casino or an airport, you know, someone where there's security system, it may still reside on its own segregated, you know, dedicated security network. But what we're seeing right now is that, you know, we are logically separating things through VLAN. So we are having one common base building network. We're still, you know, segregating all of these systems through, you know, virtual local area networks, the VLANs, which can all have their proper security and also their proper plugins, so that we can still share data between the VLANs without actually having the traffic on the same VLAN. But more recently, we're seeing OT networks, you know, being somewhat separated from corporate networks, right? So I have an OT network, which has all my base building systems. I have my corporate network, which has all of my business related systems. And they are, you know, gatewayed or networked together to some extent so that they can share the data that's needed to be shared, but they are segregated. So should, you know, the BSN be compromised, the OT network, that, you know, all my commercial information isn't at risk. So it's really up to the client.
Perfect. Thank you.
Are we going to be safe from supply chain problems for maintenance? I mean, so we've seen the biggest supply chain issues, I think, with, you know, long lead times and electronics. I mean, even right now, if you talk to some of the major network players like Cisco and that, depending on, you know, who you are as a client to them, you could be looking at, you know, 6 to 8 month wait times to get network switches just based on chipsets availability and that. So, you know, there's no hiding from the supply chain issues right now, especially on the electronic side of things. Is it going to get better with time? I think absolutely. You know, once, you know, all this needs to settle down a bit, but yeah, we're definitely being affected. Anything electronic with chips.
I guess that's the reality.
Yeah, across the board. I think if there's no enforcement from governments, any advanced technologies like BI might be more considered as a nice to have, like self-driving cars. And I think to some extent you're right. So I think, you know, eventually we might get to a point where, you know, you need to hit certain targets, which may be somewhat, you know, guided or standardized, and how you hit those energy targets will be up to you. And you know what, a good solution for that will be building intelligence to most. So I think maybe through some indirect avenues, we might get some light level enforcement, but I think for right now, you know, I think everyone is just doing it on their own because there are benefits, you know, to bottom line as well. But yeah, and it, you know what, if the world gets to a point where climate and climate change and that is really becoming catastrophic, then, you know, governments around the world may need to come to some sort of enforcement. But, you know, I think we're a bit away from that.
Perfect. Wow. We've cleared maybe 20 or some questions. Mike, good job.
See that? But yeah, no, that's, you know, I could talk about this for hours.
Now the floor is open. Anybody wanted to unmute themselves, open up the camera, and just discuss any topics you would like to discuss with Mike? Now is the time.
Mike, may
Yeah.
I have a question? So I'm wondering, because we are moving the action at the regulatory body to making some changes for like regulatory settings for like building code, something like that. Do you see there is some potential action the regulatory committee could make effort to help the engineering world interpret the building intelligence in a more quick or widely way that can help mitigate the climate change?
Yeah, so I think like right now we're starting to do that. So like I said, right now we're still at the executive committee level for CSA, Canadian standards for building intelligence. All of these major, ASHRAE is another one which continues to, raise the bar. LEED continues to evolve and raise the bar for energy targets and for LEED points. So I think, all of these individual accreditations, and there's items like Wired Score and Smart Score, different certifications you can get for your buildings and your assets that continue to evolve. So, where LEED started, let's say 10 years ago, right now is so commonplace that, it evolved. Now to hit your LEED marks, you need to be so much better. Same with ASHRAE, same with TGS, same with all of these standards. So I think they are continuing to raise the bar and making it normal to only continue to advance.
Thank you, Mike. Thank you so much for your insightful presentation today. I would give our greatest participants for all audiences for their showing up today. For sure, we have a long way to go on climate action, and hopefully you all get some insightful takeaway from Mike's presentation and will take some action after this seminar in your daily practice. Engineers have great responsibilities in building a brighter future for human beings, and we should see ahead when we design, build, and operate any projects. So I will just give some very simple comments for this seminar. And if you are interested in attending our future seminars, please follow us on our linking page that we shared in the chat box, and follow us on the YouTube channel where we will post all the video recordings for the seminars and also as the presentation slides. So I would like to give it back to today's seminar chair, Aya, to give some closing comments.
Thanks, Kirsty. Thanks, Mike, for the great presentation. Really enjoyed listening to you. It was really insightful and very informative. And I hope everybody in the call enjoyed the seminar and got some insight and takeaways. As Kirsty mentioned, take action as engineer from today or maybe from now on getting involved and implementing some of these technologies in the building from now on. With that, I would like to thank everyone. If no one has any question or comments, we will adjourn the meeting officially. All right, everyone, have a good night and thank you.
Thank you. Have a good night.
Thanks, everyone. It's been my pleasure.
Good night, everyone.
Thank you. Good night.